Hello, my name's Kevin, and welcome to the first video of two to introducing the nature of substances and chemical reactions. In this video, you should be able to have an understanding of how products arise from reactants, a change in state results in a reaction occurring, use chemical names to show chemical reactions, and using chemical formula to show a balanced reaction where the total relative mass of reactants and products are equal. This slide will focus on the different states and elements. These states should be nothing new to you, and this should be revision. These revision resources I have given is a table to show that solid is represented by S, gas is represented by G, liquid is L, and aqueous is AQ. We should know aqueous is dissolved in water. Here's a reaction of a carbonate reacting with an acid to show different states. In this reaction we have a carbonate reacting with a nitric acid to give aqueous, one gaseous mole and one liquid. Therefore, this means a change in state has occurred, therefore a reaction has occurred. You should know these symbols and you should learn the elements, which will give you a better understanding of how to name these. If you want further information about these elements, I recommend reading The Disappearing Spoon. It's a good way to introduce yourself to the periodic table if you want to pursue chemistry more. To clarify conservation of mass, mass cannot be gained or lost. This is similar to Newton's first law of conservation. Therefore, atoms cannot be lost or gained in a chemical reaction. Meaning, total mass or molecular mass of the reactants are equal at the beginning and at the end of the reaction. Take this image for example. If we look to our periodic tables, we can find that copper in the transition elements has a molecular mass of 64. Two coppers therefore have a molecular mass of 128, whilst the molecule of oxygen has a molecular mass of 32, each containing 16 in one atom of oxygen. When they react, we are given two copper oxides. One copper oxide, 64 plus 16, gives a molecular mass of 80. Therefore, once we times both of them together, we get 160. We can see, similar to the beginning, it's also 180. Therefore, we have not lost any molecular mass or gained any molecular mass. This information is good to calculate moles, mass, or molecular mass, depending on what we're given in the equation. I recommend BBC Bitesize as a further revision resource if you need it. To learn how to balance equations, we use what we learned with the conservation of mass. Pause this video and attempt to do this by yourself. Hopefully you guys have done it. In this equation, we see that on the left-hand side in the reactants, we have one atom of magnesium, 2 of oxygen, 3 of hydrogen, and 3 of chlorine. And in the products, we have 1 of magnesium, 1 of oxygen, 2 of hydrogen, and 2 of chlorine. Now that we know that from the conservation of mass, that atoms are not gained or lost, we now need to try balance them to have the similar atoms. Balancing the equation is a lot easier said than done. Here, hopefully you can see that the OH is being times by 2, therefore we have 2 OHs, and that's why we have 2 oxygen atoms and 3 hydrogen atoms from the 2 hydrogens and 1 hydrogen here. First, let's attempt to balance out the easiest element and products in the HCl, the hydrochloric acid. We see that we have 2 atoms of chlorine on the right hand side and we need 2 atoms of chlorine in the left hand side. Therefore, what we do is we times hydrochloric acid by 2, allowing us to have 2 atoms of chlorine on the left and 2 atoms of chlorine on the right. Now that we have 2 HCl and 2 MgOHs in 2 hydrogens there, we now have 4 instead of 3. Now that we have a common multiple, all we need to do is times the atoms on the right hand side to get the same as on the left hand side. So what we can do is put a 2 in front of water, H2O, to have 4 atoms of hydrogen and 2 of oxygen. Hopefully from this you can see that we now have one magnesium on the left, one magnesium on the right, 2 atoms of oxygen on the left, 2 atoms of oxygen on the right from the 2 in front of the H2O, and then we have 4 atoms on the left from the 2 on the magnesium hydroxide and the 2 in the hydrochloric acid, and 4 hydrogens on the right from the 2 in front of the H2O, allowing us to have our final products. Now try this equation and replace the atoms with a molecular mass. If you also want to challenge yourself, try go online and find some in also BBC Bitesize is a great website. You can also try balance these equations using oxidation numbers. This is a lot harder, however it will be more precise in the future. For example, magnesium has a charge of 2 plus and oxygen has a charge of 2 minus. These will commonly come together to make magnesium oxide. However, in this equation we have magnesium hydroxide, which means we have an OH group. The OH group has a charge of -1. This is due to the hydrogen having charge of +1 and the oxygen 2 minus. Therefore, they go together to form -1 or 1 minus. So to balance the equations, we need 2 OHs for the 1 magnesium, balancing out the 2 plus charge with a 2 minus charge here in total. Similarly, we see in the magnesium chloride that magnesium's 2 plus and a chlorine atom is -1. So we need 2 chlorines to balance out the magnesium. To summarize, in this video, you should have an understanding that products arise from reactants, a change in state results in a reaction occurring, use chemical names to show a chemical reaction, and using chemical formula to show a balanced reaction where total relative mass of the reactants and products are equal. As we did in the previous slide, we showed how atoms are equal in the products and reactants. You could do the same with the relative mass.